All right. Good evening, everyone. I hope you are doing fine. So in this video, we are going to answer chemistry tutorial sheet 2. Okay, so as you can see, these are the questions here. We have one question, two, three, four, five. So we're going to solve all these questions in this tutorial sheet. All right, so let's go on our board here and begin solving question number one. So question number one, they're saying complete the following table. And then this table has four columns. The first one has the mass, the second one has the moles, the third one has the molecules, and then the fourth one has the atoms. Okay? So in order for us to fill in all these blank spaces that you can see here, okay, we need to know two important formulas. Okay? The first one is the formula that relates the moles, the mass, and the molar mass. So that's the formula that we use to calculate the moles if you are given a mass of a certain substance. Okay, so we have to know that the moles, okay, are equals to the mass divided by the molar mass. So this molar mass here, okay, you get it from the periodic table. If it's a group of compound, okay, you get the individual molar masses, you add them for you to find the molar mass of that compound. Okay, so there's a video on the website on this. Even on my YouTube channel, you can check how to find the molar mass. Okay, so this is the first relationship that we need to know. And then the other relationship that we must know, okay, the other relationship that we must know is that one more of anything, okay, one more of anything contains 6.02 multiplied by 10 to the power 23 particles. Okay, this is the second relationship that we must know. And that particles here, okay, the particles can be the molecules. They can also be the what? Atoms. They can be electrons. And they can be ions. Okay, so one more of anything contains the Avogadro's constant number of what? Particles. So this number here, the 6.023 is the Avogadro's what? Constant. All right, so once we know these two relationships, then we can come to this table and we can try to fill it in. Okay, so in the first row here, okay, we've been given 0.175 moles of carbon dioxide. Okay, and then the number of molecules we have nothing, number of atoms we have nothing, even the mass here we have nothing. So by the fact that we've been given the moles of this carbon dioxide here, okay, we can use that to find the mass, the number of molecules, and the number of atoms. Okay, so what we need to do here is, first of all, calculate the molar mass of carbon dioxide. So we're going to say molar mass, okay, of carbon dioxide is given by, okay, the molar mass of carbon, which is 12.02 plus, okay, the plus 2 multiplied by the molar mass of oxygen here. Because this oxygen has like a 2 there, no wonder we are multiplying it by 2. So the molar mass of oxygen we can get as 16. So when we add this, what are we going to get? So 12.01 plus 16 multiplied by 2 is a 32. So I'm going to get my molar mass of the carbon dioxide as 44.01 grams per mole. Okay, so this here is our molar mass. Okay, so once you get your molar mass, we know that from this formula that I wrote here up, okay, we can be able to find the mass. Since now we have the moles and the molar mass. So you can use these moles that you have and the molar mass to calculate the mass. So if I make mass the subject of the formula, okay, so first of all, let me just write the normal formula. So moles indicated by N is equals to the mass divided by the molar mass. So if you want to find the mass here, you make it the subject, so you cross multiply here. So what you're going to get is mass is equals to moles multiplied by what? Molar mass. Okay, so the moles, we get it from the table. It is just 0.175 moles multiplied by the molar mass is 44.01. So when we multiply this, we should be able to get the mass of that carbon dioxide. So 0.175 multiplied by 44.01. Okay. When I do that multiplication, I'm ending up with 7.70175 grams. So this here is the mass of what? The mass of carbon dioxide. Okay, so you make sure that you round off this to three significant figures. So if we round off this to three significant figures, it's going to be 7.70 grams. So this 7.70 grams, I'm going to write it here as the mass of the carbon dioxide. All right, so any questions there as how we have found this mass of carbon dioxide? Any questions there? Okay, so if there are no questions, then we can move on now and use, um, we can go on now and use this number of moles that we've been given there, okay, to calculate the number of molecules in the sample and finally the number of atoms. All right, so to calculate the number of molecules, we are going to use this relationship here. We are going to say 1 mole of carbon dioxide contains 6.022 multiplied by 10 to the power 23 molecules. Okay, and then since now we have the moles of the carbon dioxide, we are going to say what about 0.175 moles of this carbon dioxide? How many molecules is it going to have? So you cross multiply here. Okay, so when you cross multiply, you're going to get x is equals to 0.175 multiplied by 6.022 multiplied by 10 to the power 23. So the value that you are going to get there will be the number of molecules of this carbon dioxide. So just go on your calculator, you punch 0.175 multiplied by 6.022 multiplied by 10 to the power 23. Okay, so when you multiply that, I'm getting my answer as 1.05385 multiplied by 10 to the power 23. So make sure you counter check with your own calculators as well. So you confirm if I'm finding the correct answers there. All right, so that will be 1.05385 times 10 to the power 23 molecules. Okay, so remember these are molecules of what? Carbon dioxide. Okay, so we can um, write that number to three significant figures. Okay, so if you write it to three significant figures, it's going to be 1.05, okay, multiplied by 10 to the power 23 molecules of carbon dioxide. So we are going to get this value here and write it in the table here. So the number of molecules in the sample will be 1.05 multiplied by 10 to the power 23. So these will be the molecules, okay? So now once we have the molecules, then the atoms are very easy to find, okay? Once we have the molecules, the atoms are very easy to find. Please guys, if you have any question, just unmute yourself and ask, okay? So what we have to know is that, okay, one molecule, okay, one molecule of carbon dioxide has a total number of 3 atoms. Okay, so how do we count these atoms? We see that we have one carbon there, which is one atom, and then we are having 2 oxygens here because this oxygen has this two. So these are 2 oxygens. So we have one carbon plus 2 oxygens. So 1 plus 2 gives us what? 3 total atoms. Okay, so if in one molecule we have 3 atoms, what about in 1.05 multiplied by 10 to the power 23 molecules? Okay, how many atoms are we going to have? So you cross multiply, what you're going to get is x multiplied by this one is going to be x, which is equals to 3 multiplied by this number. Okay, so 3 multiplied by 1.05 0.05 times 10 to the power 23. It's going to give me 3.15 multiplied by 10 to the power 23 atoms. Okay, so in this much of the molecules, we have this much of the what? The atoms. So you can get this number and put it here. Okay, so 3.15 times 10 to the power 23 atoms. Okay, so it means we are done with the first one. There are any questions before we fill in this second row here? Any questions? All right, so if there are no questions, I'll proceed to the next one. Okay, so the next one now, we have an empty mass, empty number of moles, empty number of molecules, and then we just have the number of atoms in this sample. Okay, so this sample here is C2H5OH. Okay, so C2H5OH. So this is what we have there. Okay, so the first thing that we are going to do is convert this number of atoms that we can see here, okay, to the number of molecules. Okay, we're going to convert them to the number of what? Molecules. So what are we going to do? We are going to say that one molecule of this C2H5OH contains how many atoms? Okay, so 2 plus 5 plus 1 plus 6. So that is, 2 plus 5 plus 1 plus 1. So that will be like 9 atoms. Okay, so one molecule of this C2H5OH contains 9 atoms. Okay, what about if I have these number of atoms here? How many molecules am I going to have here? So I'm going to write 9.48 multiplied by 10 to the power 21 atoms. Okay, so this number of atoms, how many molecules are we going to have there? Okay, so you just cross multiply. You're going to have 9x is equals to. Okay, so remember here it was one molecule of this. So we have this number of atoms multiplying by one molecule. You're just going to have 9.48 multiplied by 10 to the power 21. So you divide this side by 9, even this side you divide by 9. So it means our x will just be equals to, okay, so let's divide that number on top by 9. So 9.48 times 10 to the power 23 divided by 9. Okay, so it's giving me 1.053333 times 10 to the power 21. Okay, so now these are what? Molecules. We've converted those atoms to molecules. So these are molecules now. So we can round this off to 3 significant figures. It's just going to be 1.05 times 10 to the power 21 molecules. So this is the value that I'm going to get, and then I'm going to write it here in the molecules column. So it will be 1.05 times 10 to the power 21 molecules, okay, of this C2H5OH. All right, so now that we have the number of molecules, we can find the number of moles, and finally we can find the mass. Okay, so we're going to say one mole of anything contains 1.05 times 10 to the power 20. No. Okay, I went ahead of myself. So one mole of anything contains 6.022 times 10 to the power 23 molecules. Okay, and then from these molecules, we can calculate, from this formula, we are going to say that what if I have 1.05 times 10 to the power 21 molecules? Okay, how many moles am I going to get here? So simply cross multiply. We are going to have 6.022 multiplied by 10 to the power 23x is equals to 1.005 multiplied by 10 to the power 21. Okay, so we want to find the value of x. So it means we're dividing by 6.022 multiplied by 10 to the power 23. Even this side, we are going to divide by 6.022 multiplied by 10 to the power 23. Okay, so we see that on the left-hand side, this is going to cancel. So we are just remaining with x is equals to, and then we are dividing this now. Okay, so let's divide that on the calculator. So we are going to say, okay, we're going to say, let's divide it in phases. Okay, so 1.05, 1.05, let's divide it by the 6.022. So if I divide the 1.05 with the 6.22, I'm getting 0.1744. Okay, and then now let's divide this 10 to the power 23 and this 10 to the power, this 10 to the power 21 and this 10 to the power 23. So here we are dividing exponentials that have the same base. They both have 10 and they are dividing. So if they are dividing, that will it will just mean you write the same base and then you subtract their powers, which is 21 minus 23. So this is going to give me 10 to the power minus 2. Okay, that is going to give me 10 to the power minus 2. So I'll come here and say 10 to the power minus 2. So we can now change that. Okay, we can now change that to a decimal. So what we are going to do is we're going to say x is equals to, so 10 to the power negative 2. So just get that number and then multiply it by 10 to the power, okay, 10 to the power minus 2. Okay, so if I multiply that, I'm getting this as my answer. I'm getting 1.744 multiplied by 10 to the power minus 3. Okay, and these will just be what? Moles. Okay, so those will be our moles for C2H5OH. So you come here and write your moles, which will just be 1. Let me use red, which will just be 1.744 multiplied by 10 to the power minus 3 moles. Okay, so that is what we get there. That's what we get. And then from there, okay, since we now have the number of moles, we can find the mass. Okay, so remember to find this mass here, okay, the mass that will be there, we're just using this relationship here. Okay, so we know that moles is equals to mass over molar mass. So if we make mass the subject of the formula, it will be mass is equals to moles multiplied by the molar mass. Okay, but here it means we have to calculate the molar mass of this guy. So the molar mass of that guy will be 2 multiplied by 12.01. This 12.01 is the molar mass of carbon. You get it from the periodic table, plus 5 multiplied by 1.01. This here is the molar mass of hydrogen, okay, plus the molar mass of oxygen plus the molar mass of hydrogen, like that. Okay, so let's calculate that molar mass. Okay, so when I add all that, I'm getting my molar mass as what? Okay, so 12 plus 12.01 plus 5 multiplied by 0.1 plus 16 plus 1.01. I'm getting my molar mass as 46.08 grams per mole. So this is the molar mass of this C2H5OH. Okay, so I'm going to place it in this formula. So our mass will be equals to 1.744 multiplied by 10 to the power minus 3 multiplied by, okay, we're going to say multiplied by, and then we have the molar mass here, which is 46.08. So when we multiply this, what are we going to get? Okay, so just multiply this number here with this first number here. Just leave this 10 to the power something on its own. So it will be 1.744 multiplied by 46.08. Okay, so there I'm getting 80.36. Okay, you can just end there, multiplied by 10 to the power minus 3. But we have to express this in scientific notation. So we move this point one step to the left. So if you move one step to the left, it means you add a power to this 3. So that will be 8.036 multiplied by 10. Then if I add 1 here, okay, it will just be minus 2. All right, so that will be grams. So that will be our mass. So you come here on your box for the mass, you write 8.036 multiplied by 10 to the power minus 2 grams. All right, so any questions there? We are done with question 1. Any questions there? Okay, so if there are no questions, let's look at question number 2. So question number 2, they are saying a sample of hydrate a sample of hydrate iron sulfate, okay, has a mass of 2.5. Okay, has a mass of 2.5 grams. How many molecules of hydrogen are contained in this hydrate? Okay, so hydrate, guys, simply means a certain compound is combined with water. Okay, that's what it means. So here we have this iron sulfate, okay, combining with what? The water there. That's what it simply means to be hydrate. So here they're saying how many molecules of hydrogen are contained in this hydrate here. Okay, so let's first of all write the mass of the hydrate that will be given, which is just 2.5 grams. Okay, and then let's write the formula of the hydrate, which is just FeSO4 and then 0.7 H2O. All right, so for us to find the molecules contained in this iron sulfate, okay, we just look at the number that we have here. Okay, so we know that if I write, we know that the hydrogen molecules, okay, are represented by H2, like this. So this here is one hydrogen molecule. Okay, whenever you see H2, that's one hydrogen molecule. Or you see O2, that's one oxygen molecule. Or you see, what can it be? Fluorine 2, that is one fluorine molecule. Okay, so in just this formula here that I've written down, how many hydrogen molecules can we see? Okay, we can see we have a 7 in front of the H2. So this H2 on its own here is one molecule. And then I have a 7 in front. So 7 multiplied by 1. So in this formula, just the formula alone, we can see that we have 7 molecules of what? Hydrogen. Okay, we have 7 molecules of hydrogen just in the formula. So now here they want us to find how many molecules of hydrogen are going to be specifically there in a mass of 2.5 grams. Okay, so if I just have this formula like that, this formula represents 1 mole of this whole compound here. So our ratio is going to be in 1 mole of the compound, I have 7 molecules. Okay, 7 molecules of hydrogen. Okay, what about in the moles that I'm going to find once I divide this mass here by the molar mass of this compound? Okay, so the molar mass of FeSO4.7H2O, okay, you have to add the molar mass of this plus molar mass of this plus 4 the molar mass of oxygen, and then plus here we can say 7 the molar mass of water. Okay, so let's find the molar mass of that compound there. Okay, so we are going to add the molar mass of iron. Okay, so what is the molar mass of iron? So let me check the periodic table here for the molar mass of iron. I don't have it on the screen there. So you also check your periodic table. Okay, so the molar mass of iron is 55.85. So I'm going to write 55.85. You get this value from the periodic table, guys, plus the molar mass of sulfur, okay? So the molar mass of sulfur is going to be 32.07. If you round it off to 2 decimal places, plus 4 multiplied by the molar mass of oxygen plus 7 multiplied by the molar mass of water. So water there, we're adding 2 multiplied by 1.01 plus 16. So this is going to be 18.02 like this. So this here is the molar mass of water. So 7 multiplied by the molar mass of water, which is 18.02. Okay, so now let's find the total when we add all this here. So when I add all that, I'm getting my molar mass of hydrated iron sulfate as, okay, my molar mass of hydrated iron sulfate, I'm getting it as, okay, let me add. So we have 55.85 plus 32.07 plus 4 multiplied by 16. So that will just be a 64, right? So plus 64. And then plus 7 multiplied by 18.02. Okay, so when I do that, I'm finding my molar mass to be 278.06 grams per mole. Okay, so this here will be my molar mass for this compound that I can see on top there. So let's erase some of these things here. Okay, so molar mass of hydrated iron 2 sulfate is just 278.06 grams per mole. So this is our molar mass here. Okay, so it means now we can use this mass and this molar mass to find the moles. So we're going to say moles is equals to the mass, which is 2.5, divided by, okay, the molar mass, which is 278.06. So what do you get when you divide this? So it will be 2.5 divided by 278.06. Okay, so that is going to give us 8.99086528 times 10 to the power minus 3. Okay, so counter check if your calculator is also giving you the same answer there. So we can round off this to 3 significant figures. So it's just going to be 8.99 multiplied by 10 to the power minus 3. So these here are the number of moles, okay, of the hydrated iron 2 sulfate. So now remember the relationship, okay? Just by looking at this formula here, we can see that if we have one more of this, then we have 7 molecules of hydrogen there, okay? So 7 multiplied by hydrogen like this. This means 7 molecules of hydrogen. So this is the relationship that I've written there here. Okay, so one more of that compound has 7 molecules of hydrogen. What about if I have this number of moles, 8.99 times 10 to the power minus 3? How many molecules am I going to have? So cross multiply x multiplied by 1 to be x is equals to 7 multiplied by this number. Okay, so 8.99 multiplied by 7 multiplied by 10 to the power 3, to the power minus 3, I mean, multiplied by 10 to the power minus 3 is going to give me what? Okay, so this here is going to give me 6.293 multiplied by 10, okay, to the power minus 2. So this here will be the number of molecules. Okay, so we are going to say molecules of hydrogen like that. All right, so any questions there on how we are finding the number of molecules of hydrogen contained in that hydrate? Okay, so let's look at B. So at B, we are basically using the same principle. Okay, so now let's read the question and then understand it. Okay, so on B, they're asking us how many moles of water, okay, how many moles of water would be released during the dehydration process. So dehydration here simply means you are removing the water. So we want to remove this 7H2O from this compound here. So how many moles of water would be released during the dehydration? So from the formula, we know that one mole, okay, from the formula there, we know that one mole of this compound, okay, has how many moles of water? Okay, it has 7 moles of water like that. Okay, it has 7 moles of water. Let me write it like this: 7 moles of water. Okay, so how do you find this ratio? You just get the ratio of this whole compound to the moles of water that you have. So this whole compound is just 1. And then we can see that it contains 7 waters like that. Okay, so it means one more of the whole compound that we have here has 7 moles of water. Okay, so if one more has 7 moles of water, what about this compound now that has this number of moles here? Remember, we found the number of moles of it, right? So what if we have these moles here? How many moles of water are we going to have? Okay, so we are going to say, what if I have 8.99 times 10 to the power minus 3 moles of this compound? Okay, how many moles of water am I going to have? So you cross multiply, you're going to have x multiplied by 1, just be x is equals to, and then this number here multiplied by 7. What are you going to get? Okay, we're going to get uh, we're going to get a similar number that we did on the the molecules of hydrogen. Okay, so we are going to say 8.99 multiplied by 7. Okay, so 7 multiplied by that, we are going to get 6.293 multiplied by 10 to the power minus 2 moles of water. Okay, so this here is our answer. So any questions there? All right, no question. Let's go to question number 3. So question number 3 is on the empirical and the molecular formula. Okay, so the question reads, they're saying a compound contains only sulfur and nitrogen. So meaning this compound is in this form, S, X, and then nitrogen, Y. So we just have to find the value of Y and the value of X there. So they're saying this compound contains only sulfur, nitrogen. It contains only sulfur and nitrogen. Okay. And then they're saying nitrogen is 69.6% by mass. Okay. And the molar mass of this whole compound, we have been told it's 184 grams per mole. So what is the empirical formula? Okay. And then again, what is the molecular formula? So we know that we have to, for us to solve this question, we have to know the percentage of the nitrogen, and we also have to know the percentage of the what? The percentage of the sulfur. Okay, so here they're saying what? A compound contains only sulfur and nitrogen is this by mass. So it means the mass of The percentage mass of nitrogen is that 69 point something there, right? Oh, okay, okay, I see. So that percent there is for the sulfur, because here they're saying, okay, let's read it together. They're saying this compound contains only sulfur and nitrogen, and then they're saying 69.6% sulfur by mass. So this 69.6 is the percent for sulfur. So we're going to say percent for sulfur plus percent for nitrogen should give us what? 100%. Since this compound contains only those two. So for the sulfur, we have 69.9. I mean 69.6. And then plus percent of the nitrogen we do not have is equals to 100. So percent of the nitrogen is just going to be equals to 100 minus 69.6. So let's subtract. So if you subtract that, I'm getting 30.4%. Okay. So the sulfur is 69.6%, and then the nitrogen is 30.4%. So I'm going to write here sulfur is just 69.6%, and then nitrogen is 30.4%. So once you have your percentages there, then it will be very easy for you to find the uh, the empirical formula. Okay, so the empirical formula is the simplest formula that you can get. And then this molecular formula is actually a factor of the empirical formula, meaning you have to multiply the empirical formula by a certain factor for you to find the molecular formula. Okay, so first of all, we find the empirical formula. So the empirical formula is found by the same series of steps. Okay, so step one is we are going to write element. Okay, and then you list down the elements that are contained in that compound in order that they are mentioned. So here we had sulfur and then nitrogen. So I'm going to write sulfur and then nitrogen there. Okay, after that, you write the mass percent here. Okay, so the mass percent for sulfur is 69.6. The mass percent for nitrogen is 30.4. Okay, and then after that, you'll find the moles. Okay, so how do we find the moles? Remember, moles is equals to mass over molar mass. So we divide this percentage mass here by the molar mass of sulfur, even this percentage mass by the molar mass of nitrogen. So this is going to be 69.6 divided by the molar mass of sulfur is about 32.06. And then here it's going to be 30.4. The molar mass of nitrogen is about 14.01. Okay, so let's divide and then see what we're going to get as the moles there. So the moles here will be this number divided by this. I'm getting 2.170295072. And then here when I divide, I'm getting 2.1698 98786581. Okay, so from there, we are going to find what we call as the ratios. That will be in the formula now. So let me represent it by a different color. So ratios here. So always follow the same format that I'm doing here whenever you're finding the empirical formula. So for us to find the ratios here, we are going to look at these two number of moles that we have there. Okay, so we look at those moles and then we decide which one is the smaller number among those two. So this is 2.17, this is 2.16. So it means this one here is the smaller number, right? So to find the ratio, we are going to divide the first number of moles, okay, by the smaller number that we have, which is 2.169878 786581. And then even this one here, we're also going to divide by the smallest number of moles, which is itself like that. So we divide this by 2.1698786581. All right, so when we divide this, what are we going to get as our ratios? Okay, so let me erase the one that I have on above. So when I divide this, I'm getting 1.0004842,893. And then when I divide this, since it's the same number, we're expecting to find what? 1. So it means the ratio is just 1 to 1. Okay? If I round off this here, it will just be 1. So it means our empirical formula is just going to be equals to S with a 1 and then nitrogen with a 1. But if it's a 1, we don't write it. So we just write SN like that. So this here will be the empirical formula. Okay? So any questions there? Okay, so since there are no questions, let's find the molecular formula now. So now that we have the empirical formula, we can find the molecular formula. So the molecular formula is equals to the empirical formula multiplied by what we call as a factor here, this N. So that N is found by, okay, that N is found by the molecular formula mass, which is also known as the molar mass of the compound, divided by the empirical formula mass. So the molecular formula mass here is the same as the molar mass that you have there. Okay, so that is 184, and then divided by the empirical formula mass. You go to your empirical formula and then you add, okay, the molar mass of S plus the molar mass of N. So when I add that, I'm going to get 46 point 46.07. Okay, so it means here I'm going to divide by the empirical formula mass, which is 46.07. So how do we find it? Just get the molar mass of sulfur on your periodic table plus the molar mass of nitrogen. Okay, so when I divide this, what am I going to get? I'm getting 3.9939. Okay, we can end there. So I'm going to round off this number. So it's going to give me what? 4. Okay, so that 4 there, it means it is our N there. So I'm going to say my molecular formula is just equals to, okay, the empirical formula, which is Sn multiplied by a 4. So when I multiply that, what do I get as my molecular formula? S4N4. Okay, so this here is our molecular formula, and then that there is our empirical formula. So we've answered this question. So unless there are any other questions that we need to do, okay? Any other questions? All right, so if there are no any other questions on 3, let's solve question 4. Okay, so question 4 is also on the empirical and the molecular formula. So we are going to follow similar steps that we did on the previous question there. Okay, so we're going to say, okay, let's read the question. So the question states, a certain acid has an organic compound composed of 41.39% carbon, 3.47% hydrogen, and the rest is oxygen. Okay, if 0.129 moles of this acid, okay, has a mass of 15 grams, what is the empirical and the molecular formula of this acid? All right, so the first step is to find the mass percentages of all those uh, elements that are contained in that organic compound. So we've been told that this organic compound contains carbon, hydrogen, and oxygen. So this it will be to a certain number. We can say X, Y, and then Z. So we want to find these XYZ there to find the molecular or the empirical formula. So the first step is to find the percent of carbon, percent of hydrogen, and the percent of oxygen. So we've been given the percent of carbon, we've been given the percent of hydrogen. Okay, we are remaining with the percent of oxygen. So we know that if we add the percent of carbon plus percent of hydrogen plus percent of oxygen, we should get 100%. Okay, so it means the percent of oxygen, okay, the percent of oxygen here is just going to be equals to 100 minus the percent of carbon, which is 41.39, plus the percent of hydrogen, which is 3.47 there. All right, so let's add and subtract. So when we add that and subtract, my calculator is saying what? So make sure you counter check with yours too. Okay, so it's giving me 55.14%. So this 55.14% will be the percent for the oxygen. So I'm going to say carbon has 41.39%. Hydrogen has 3.47%. And then oxygen, we are finding here that it has 55.14%. All right, so once you have your percentages, we can start the process of finding the empirical formula. So we're going to say the first thing is element there. Okay, so element, we have carbon, we have hydrogen, and then we have oxygen. The next thing is to write your mass or your mass percent. So the mass percent of carbon is 41.39. Mass percent of oxygen, hydrogen here will be 3.47. And then the mass percent of oxygen is 55.14. Okay, so after you find your mass, you go on to find the moles. So the moles, you are dividing that mass percent by the molar mass of carbon, which is 12.01. Okay, here we're going to divide this percentage mass of hydrogen by its molar mass, which is 1.01. And then here it will be 55.14 divided by its molar mass, which will just be what? 16. Okay, so once you divide those, you're going to have moles here. So I'm going to have here 3.4462947. Okay, I can end there. And then here when I divide, I'm getting 3.43564.3. Okay, and then at the end here, if I divide 55.14 divided by 16, I'm getting 3.44625. All right, so of these numbers that we found here and here and there, which one is the smallest? So we can see that this one is 3.44, this one is 3.43, this one is 3.44. So it means this one here is the smallest. So we're going to divide all these by this smallest value there. Okay, so we're going to say ratios. Okay, so the ratios will be this 3.4462947 divided by the smallest number, which is this one. So 3.435643. And then itself, we're going to divide it by itself. So we divide it by itself. And then the last one, we're also going to divide it by the smallest number of moles, which is just 3.43563. Okay, so when we divide that, we have to get the ratios there. Okay, we have to get the ratios. So here when I divide, I'm getting 1.0031002023. And then here, I'm going to get exactly 1 because these are the same here. Okay. And then there, what am I going to get? I'm getting 1.003087178. Okay, so this is what I get here. And then I can round off. So it means here it will just be 1, there it will just be 1, there it will just be 1. So the ratio of carbon to hydrogen to oxygen will just be 1 to 1 to 1. So it means the empirical formula will just be CHO. Okay, so any questions on how we found the empirical formula? Okay, so we proceed now to find the molecular formula. So the molecular formula, we know that the molecular formula is just equals to, okay, the empirical formula multiplied by a factor n. And this factor n is found by the molecular formula mass, which is also called the molar mass, okay, divided by the empirical formula mass. So it just means we have to find the molar mass and the empirical formula mass there. So notice that in this question, we've not been given directly the molar mass. Okay, we've been given instead the moles and the mass. So we can calculate the molar mass from there. So we know that moles is equals to mass over molar mass. So it means molar mass will just be equals to mass over what? Moles. So let's calculate. So the mass, okay, is 15 divided by the moles, which is 0.129. So when I divide this, I'm going to get the molar mass. Okay, so I'm finding what am I finding there? I'm finding 16, so 116.2, let's say 8, okay, grams per mole. So I'm finding this as my molar mass. Okay, so I'm going to say my molecular formula mass, or my molar mass, is just 116.28. All right, what about the empirical formula mass? So the empirical formula mass, you get it from the empirical formula. So we are going to add the molar mass of carbon plus, okay, so 12.01 plus the molar mass of hydrogen, 1.01 plus the molar mass of oxygen, which is 16. So when I add this, what am I going to get as my empirical formula mass? Okay, I'm going to get 29.02 grams per mole. So this is my empirical formula mass here. So I'm going to get that empirical formula mass. Okay, so we're going to say N is equals to the molecular formula mass, which is 116.28, divided by the empirical formula mass, which is 29.02. So when we divide this, I'm getting 3.9972432,805. So round off this to a whole number, we are going to get 4. So it means our N is 4. Okay, so N is 4. So if our N is 4, it means we can find now the molecular formula. So we are going to say molecular formula will be equals to the empirical formula CHO multiplied by the factor 4. So it means our molecular formula will just be C4H4O4. So this here is our molecular formula. Okay, and we are done with this question here. Unless there are other questions. Any other questions there? Okay, so if there are no any other questions, I think we are done with this paper, because the other question that is here, which is question number 5 here, we solved it in tutorial sheet 1. Okay, it was there exactly the way it is here. So you can watch this question in the tutorial sheet 1 video. All right, so any question before we close the class? All right, so thank you so much for attending. We end here today. So we've solved the tutorial sheet 1 chemistry, even tutorial sheet 2 we've solved now. All right, so have a blessed night.